Hey guys, today we're going to be looking at lesson 2.2. So this is going to be operations with complex numbers. Alright, so a complex number are numbers that have two parts, a real part and an imaginary part. You can represent complex numbers in different forms and use these representations to add or subtract numbers. So identifying different parts of a complex number. First, every complex number is written in the form a plus bi. Make sure you put this in your notes, a plus bi, where a is the real part and the number and b is the imaginary part. Identify the parts of the given complex number. So again, a plus bi. So if we're given 2 plus 6i, what is the real part? So that would be 2. And blank is the imaginary part. So 6 would be attached to the imaginary part. Alright, you can add complex numbers. To add a complex number, or to add two complex numbers, you add the real parts, and then you add the imaginary parts. So if you have 3 plus 4i plus negative 5 minus 8i, the 3 and the negative 5, those are your two real parts, so you would add those together. 3 plus negative 5 is negative 2, which is the real part. And then your imaginary parts are 4i plus negative 8i. So 4i plus negative 8i is negative 4i. To add that up, you just put them together. So negative 2 minus 4i. You can also subtract complex numbers. So to subtract complex numbers, you're going to do pretty much the same thing. You're going to put the two real numbers together. So we've got 7 minus 2, which is 5. And then you put the complex parts together. So 8i minus negative 5. Remember, a minus a negative 5 is actually plus 5. So 8i plus 5i would be 13i. And then the difference is 5 plus 13i. So again, you just combine the real parts and then you combine the imaginary parts. When multiplying, you have to multiply just like with distributive property. You have to multiply two binomials. Some people call it FOIL. FOIL is not really a good term for it. It's just a shortcut for two binomials. But essentially, FOIL is the distributive property. Alright, when multiplying and dividing complex numbers, you will once again be required to combine the real parts and the imaginary parts when simplifying. Don't forget that I squared equals negative 1, okay? I squared equals negative 1. So a complex conjugate of a plus bi is a minus bi. So this is important. Anytime you have a complex conjugate, the i's will cancel because I times I squared equals negative 1. So it's going to leave you a real solution. So complex conjugates are important. Make sure you put this in your notes. Basically, it's two binomials that are exactly the same except the sign in the middle. Alright, multiplying complex numbers. To multiply two complex numbers, again, you're going to use distributive property. So you're going to multiply 2 times 7, which is 14, and then outside, and then inside, and then your last terms. So you're going to get 14 plus 6i minus 42i, and then minus 18i squared. Alright, so this one would go here. And then you're going to substitute the negative 1 for I squared. So remember, anytime you have I squared, that equals negative 1. So that means instead of negative 18i squared, now I'm going to have positive 18 on the end. Then you can combine like terms. So I've got two real numbers, 14 plus 18 is 32. And then the 6i minus 42i gives me the negative 36. All right, and dividing, this is when you're going to use your complex conjugates. So to divide two complex numbers, you've got 3 minus 5i, and I'm going to divide that by 2 plus 7i. To divide these complex numbers, first write the ratio and then multiply the numerator and denominator by the complex conjugate. So let me pull my screen up here to where I can write on this. So I think it will be easier if you can see this worked out. So if we have 3 minus 5i over 2 plus 7i, we're going to multiply by the complex conjugate. You always want the complex conjugate of the denominator, because the denominator, we're trying to essentially rationalize the denominator. So we want the denominator to be a rational number, so it can't include an I. So the complex conjugate is the same binomial, different sign in the middle. So we're going to do 2 minus 7i. And then again, remember, if you do the top and the bottom by the same thing, anything divided by itself is just 1. So we're basically multiplying by 1. So we're just manipulating the problem. So now you're going to do distributive property on top and on bottom. All right, so let's start on top. 3 times 2 is 6. And then we have minus 21i. And then we have minus 10i. And then we have plus 35i squared. All right, and then on the bottom, we're going to do 2 times 2, which is 4. And then we're going to have minus 14i plus 14i. So the middle terms cancel. And then we have minus 49i squared. All right, again, our I squared is equal to negative 1. So now we can rewrite the top as 6. We can combine this to be minus 31i. And then this is now going to be minus 35. Because 35 times negative 1 is negative 35. And then I'm going to have 4 minus 49 times negative 1, which again is plus 49. So 49, I'm going to rewrite that here. All right, so we're going to have 4 minus 49 times negative 1 makes that plus 49. So 36 plus 6 is 41 minus 31i over 53. All right, now let's see what we have if we look at our choices here. All right. So the first thing we have to do is multiply the numerator and denominator by the complex conjugate. So let me see if I can pull this up. And then we're going to have to use distributive property. And then we're going to substitute the negative 1 for I squared. And then collect like terms. Well, let's see here. 6 minus 35. I added that wrong, so that is not. So this is going to be minus 29. I missed the negative there. So 6 minus 35 is negative 29. And that's going to be this here. And then we are going to separate the quotient into real and imaginary parts. So that's just writing it in the correct form as far as putting it in imaginary form. So this answer here is correct. If they want us to write it in the form a plus bi, that's why we separate the two terms. So it's just negative 29 over 53 minus the 31i over 53. And that's it for Learn the Math. If you have any questions, let me know.